Then we do a dot sum. Remember, if you do a dot sum without axis equals to 1, it gives us the column sum. So it kind of creates a new row, but it won't be stored in DF7. But it sort of creates a new row and adds up all the truths, remember? So it will be here 1, 0, because there are no nans, 1, 1. So 1, 0, 1, 1. And then we do a dot sum again. And this dot sum would not have worked, because if the first dot sum returns a data frame of 1 row and 4 columns, then the second dot sum would have again made a column total and we'll get again 1, 0, 1, 1. And that is not right. Fortunately, if you recall, the dot sum is an aggregating function. It reduces 2 rows into 1, right? It sort of reduces the dimension. So Python, rather pandas, would have returned up to here, would have returned a series, a snake, remember? So that when you have a dot sum of a snake, it will simply just run through the whole snake and add up the cells, and it will become 1, 0, 1, 1. Adding them up, it will be 3. Yeah. So the left-hand side will be 3. Is 3 greater than 0? It will return true, right? So when we ask the question, so oftentimes we need to decide, is my data clean? Clean as in, is there any nan or null or anything at all? So this question is very important, because if it's false, that means your data is kind of okay for the first category. Now, data might not have nan, but it may be completely noisy, right? So you cannot use the data at all. But at least we have eradicated one big source of problem. So is my data clean against nan and null? To answer that question, just run this. So data frame dot is na dot sum. Is it greater than 0? So if it's true, then it has na, and then you begin your cleanup. Okay, so we need to ask, is there a problem, right? So is there a problem with na and null? Now, another question that commonly will be needed to sort of questioned against our data frame is, give me the column names which have nan or null. So of course, if there isn't any nan or null up front, then we skip, right? But if there is, we would start to think about, okay, let's use for loop, right, for each row, for each column. No, you don't have to do that. You can do the what we call the pandas way, the Pythonic way, which is to use expressions, the data first, right? Data first kind of thinking, rather than control first kind of thinking. So for loops, check the cell, is it NA? That will be okay, that will do the job, but that's control first. But when it's control first, we tend to lose sight of the data and why are we doing this. Whereas if it's data first, we see kind of like this data, is there NA problems, right? And then we add up the problems, how many problems are there? So then it's very data first, and we're more shepherded into thinking along the lines of data processing, data analytics. Okay, so here we are doing a DF7 is NA, that's the mask dot sum. We get a series, all right, we get a series, and the series is basically 1, 0, 1, 1. And then we get, is it great? Remember, this is every column has a one, huh? So we are supposed to take the column name, right? So the series dot sum gives a 1, 0, 1, 1. Greater than 0 will return a series of true, false, true, true, right? If you're not sure why that is the case, maybe you can jot down this on your notebook or what, and then work out the series here. So the series dot sum here gives us 1, 0, 1, 1, and then we check each cell against greater than 0. So 1 is greater than 0. So true, false, true, 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 false, true, true, and then we pipe this mask, series mask, against the df7 columns series. So df7 dot columns will give us a series of A, B, C, D, correct? And then we pipe into the selector this mask of yes, no, yes, yes, true, false, true, true, right? So in after that, we'll extract out A, C, and D, and which is exactly the case. But if you just leave it here without the list bracket, you will get the panda series, which is sometimes a little bit feeling a bit distant. Right? You can see the ACD there, but it's got this pandas.core.series or something that is making it feeling a little bit foreign. So you can list convert it and get back the usual square bracket. And from there on is home territory. I'm sure you are feeling more comfortable with this. And this part is really nice because remember, everything we do here is not meant for dealing with 4 columns, 5 columns, right? I mean, we can just eyeball it, but we are dealing with 400 columns and 5,000 columns. That is the kind of thinking that we are trying to learn here. All right. So of course, I won't be drawing 5,000 columns here, but this is not to trivialize the case here. That I'm drawing 4 columns is not to mean that why are we going through such length, to find out it's ACD when I can see that it is ACD, isn't it? Okay. So think about it again. I expand it 1,000 times, and then you see the convenience that this does. Now, uh, another question: if we ask about the column names, which columns are having problems, then we deal with them. All right. Or we can also ask what are the rows, because usually the rows are the records like membership. So this person's record will be age, address, date of becoming a member, and so on, right? So all the columns are the fields, and each record is a row of a person. So which member has data issue, like a nan or null, right? That may be what we want. So here we ask generically, what give the row names which have nan or null. But that also means which member has data issue because they didn't fill in the survey, because they didn't fill in the date of birth. We therefore cannot give them COVID-19 vouchers because they didn't fill in their email address. Our marketing campaigns work less effectively, didn't reach some of our members, and so on. So which role names have problems? And by now, we can tap on the familiarity of our sort of structure here and immediately say DF7 is NA, right? That is a data frame mask because its NA is a cell by cell thing. And then do a dot sum, but this time round, not column sum, but row sum, right? It's simply adding axis equals to 1. So this part is exactly the same, other than asking sum dot sum to go horizontally. After that, we will get a sort of a column vector equivalent, but that's a series, remember? So we'll turn that into a true or false. So let's go down this way. We'll have a 2, and then we have a 1, right? And of course, when we ask, is 2 greater than 0? Yes. 1 greater than 0? Yes. So it's true, true of a series of 2 cells. So that becomes a mask series, and we can pipe that into the selector of df7 index. df7 index is going to be this guy here, right? 0, 1. Which one do I select? Turns out we select both. So it will give us a series again of 0 and 1 because we're selecting both, true, true. So when we list it, we will get both of them, 0 and 1. Okay. Now, yeah, like this here. So when we list convert it, we'll get 0 and 1. So here is a couple of quick bullet points. We can drop. That means first bullet point is there an issue? If there's an issue, what are the columns that have issues? Because not all columns have issues. What are the rows having issues? All right. And when we've discovered them, what do we do? Now, one common processing to deal with problematic nans or nulls is to drop them. So, but that is not to say that this is by default the right action or the above average recommendation. Uh, but just that, for example, if certain rows, all right, have nulls, then we might feel that because we prioritize accuracy, of the statistical analysis over sample size. So we might decide to drop those members whose records are not very complete. All right, they didn't write down date of birth, they didn't write down um, where they stay, etc. So when we have those issues, we drop them. So dropping columns or dropping rows, we can easily just run drop NA. Okay, drop any column or row, all rows or all columns. All right, having issues. So when we say drop NA, we will drop all rows. Any rows having issues, we'll drop them. And uh, if we want to drop any column having issues, at least one NA, right? Okay, then we will basically say x is equals to 1. Just steer in the other direction. Okay. And finally, we can also say use the in place equals to true to directly modify DF7. Okay, so sometimes we might want to drop NA and not have in place equals to true, and then we get a copy of it, even though it's like maybe a 5 gigabyte data frame, right? So we still make a copy of it. Why? Because when you drop rows and columns in place, at times it may be that to reconstruct back this 5 gigabyte is quite a hassle. It might be much considered much faster overall by just making a copy and test run the reduced data frame without all the NAND issues. All right. And if it works, then you continue. If it doesn't, at least you can fall back on this original data frame. So there are always considerations to be made. There's no standard way of saying this is always the best and it's always right. Just keep that in mind, because you don't want a standard way of dealing with things to prevent you from being very smartly or creatively handle specific contextual issues that are not uh, really the norm. All right, so in fact, errors are not the norm, and so we need to be very careful with the surrounding factors before we decide, oh, drop the columns and